Hello, Professor and fellow alumni. Michael David here. Today, I'm going to walk you through the code base for the real-time edge-based facial age prediction pipeline. First, I will go through my workspace tab by tab to explain the architecture and what each Python file is responsible for when I'm going to fire up the terminal and execute the main application so you can see the custom UI and our temporal smoothing algorithm working live on my webcam. I'll start over here on the right with our setup scripts. This is download final.py because deep learning weights are way too massive to store directly in a standard Git repository. This script automatically reaches out and downloads our pre-trained CaffeNet age models and our ResNet-10 face detection models directly to the local machine. Next is the fixmodels.py. Sometimes when you pull down older cafe network prototext files, they have structural or formatting quirks that will flat out crash modern OpenCV backends. This script acts as a quick utility to clean the patch those files so everything initializes smoothly. Moving over to generate analytics.py, this is a standalone matplotlib script I wrote specifically for the IEE paper. It uses raw NumPy arrays to generate high resolution IEEE formatted characters like the multi-class confusion matrix and the processing latency breakdown without needing heavy bloated libraries like SkyPy. Finally, we have the main engine, pageapp.py. This ties everything together. Up at the top, you can see our model configuration and our Adience age brackets. The real magic here is the exponential moving average EMA buffer I implemented using a DEC. Raw neural network interface jumps around a lot frame by frame, so this temporal smoothing algorithm averages out the classification history so our UI doesn't chaotically flicker. It captures the open CV video feed on device index 1, passes the frame to the ResNet SSD to find the face, runs the age regression, applies the smoothing, and renders out our custom turquoise HUD. Before we jump into the execution, I also want to quickly point out the old stuff folder over here in the Workspace Explorer. As I've demonstrated before, I use this directory to store older file versions, acting as a reliable backup system just in case I ever need to roll back any changes or reference past iterations. Now that I've explained the architecture, I'm going to run the script so you can see it in action. As the script initializes, it loads the heavy weights into memory and fires up the camera. And there we go. You can see the custom turquoise bounding box tracking my face at a solid 30 frames per second. You'll notice the age classification up top. If I shift my head around, the prediction stays relatively stable instead of flickering chaotically, which proves our temporal EMA smoothing is actually doing its job. You might also notice that my beard occasionally causes the model to guess a younger age bracket. This is a classic database bias issue, which I documented as an edge case in my paper. All right, to wrap things up, I just walked you through our asset download scripts, the analytics generator, and the main edge vision pipeline. And then we successfully executed the application to demonstrate real-time smoothed age estimation directly on the CPU. Thanks for watching.